processing objects. And you play with them in pretty much the same place. The logic processing objects and the audio processing objects each have their own separate configuration window. Audio processing objects are on the audio configuration window. If you look right there, you can see where it starts. If I click on logic, then I go to the logic configuration window. The logic configuration window starts completely blank. I've placed some objects on this one just so we can have them pre-placed in groups and take a look at how they relate to one another. But it normally starts out with just a blank slate, and then you right-click to select logic objects to place onto your configuration window. Now, I've taken the basic controls, the basic objects, and organized them into 4 groups. The first group is sources, things that start a logic chain. On the other end, there are destinations, things that end a logic chain. They actually do something. Pretty much everything else goes in the middle. We have an entire section of Boolean processing objects, which we'll talk about, and we have a whole section of others. There's all kinds of other objects. And there's a couple more advanced objects that fit into these same categories that aren't listed here. We'll get to those in the second half of the class. Excuse me. So, to start off here, let me move this out of the way so it doesn't keep popping up and blocking your view. There we go. Otherwise, it's going to drive somebody crazy, and it might be me. If it was just you, it would be fine. I don't mind that. The most basic logic chain is going to be a logic source. I'm going to drag it down here. I could right-click and place one, but then they wouldn't be these big, fat, wide ones I've created. So you wouldn't be able to see the entire word logic source. See, watch. If I place it, new logic source, it comes in small. You can't read what the heck it is, and it comes in with the object name turned on, which who cares about the object name? All we care about is object type for today. So that's why I'm copying these instead of placing new ones. Makes no difference. But here's your most simple and basic logic chain. A logic source and a logic end tied together with a wire. And the way this works is the logic end on its control panel has an indicator. The logic source on its control panel has a button. Looks like WebEx is running a wee bit slow today. There we go. When I press the button on the logic source, it turns on the indicator on the logic end. You see the little purple indicators come on here. You also see the indicator light up on this logic end. If I turn it off, it shuts off. That's logic at its most basic. Everything else is fluff and filling. Now, logic is cool, fun all by itself, but it's much cooler and much more fun once you tie it to audio, so that the things we're normally doing with the DSP actually have some effect on logic and then are also then affected by logic. And the way to accomplish that is one of the ways I should say, is to grab a control panel object from audio and drag it on top of the logic object. What we're doing when I do that, I'm not going to do it yet, but what we're doing when I do that is creating a link between those two objects. Now I could just as easily grab this control from my logic source, throw it over here on the control panel, and go through the old-fashioned process of taking this button and then shift-clicking on this button, right-click, and hitting link to link those two controls. However, since the logic source only has one possible control, so there's one button on it, if you just grab this button from the mute, drag it over to logic source, the green association window or association block appears, and now you know that when you release it, it's going to link those two. I can look over here at my links, and there's logic link from mute 1 to logic source L219. I do the same thing on the logic end and associate that with the master mute just by dragging it down there, releasing it. So what have I done? I've created a fairly useless circuit where when I mute the channel 1 or unmute channel 1, the master mute follows along. Well, I could have done that just by linking the two things. I don't need logic to do that. I could have just linked them normally and they've been doing the same thing, right? Well, that's true. However, what you can't do with linking is, let's bring a second logic source down here. And we're going to take a look at the Boolean objects, because we're going to use a Boolean object here in just a second. Where are they? There they are. The Boolean objects, named after George Boole, Francis Boole, George Boole. George Boole, 14th or 15th century mathematician, somewhere in there, a long time ago. Not like it really matters which century it was. He was the first one who came up with a codified system to explain this style of logical thought, where if A and B are both true, then C is true. And that's exactly what the AND object does. If input 1 and 2 are both on, like it just was, the output will be on. Watch the AND object on top, right there. Both inputs on, the output goes on. That's true whether the AND has 2 inputs or 25 inputs. They have to all be on for the output to go on. The OR object is that's just exactly, but it's effectively the opposite, because the OR object will turn on if any one or more of the inputs are on. If you have 14 inputs, only one has to be on to trigger the output. The NOT simply reverses whatever's coming into it. Whatever your input is, it gives you the opposite output. That one's fairly unimpressive. The NAND and the NOR, however, are pretty cool. You can do some neat tricks with them. The NAND and the NOR, to be honest, are nothing but, the NAND is a AND with a NOT after it. And the NOR is an OR with a NOT after it. But just like the AND up here on top says, I'll turn on my output when all the inputs are on, the NAND turns off the input when all the inputs are on. The NOR turns on the input when anything is turned on. The OR turns off the output when anything is turned on. So we get a lot of combinations of what we can have going on with those. Do all kinds of fun stuff. Now, how we can use those, there it is. The way we can use those, I had to put my cheat sheet up here and make sure I do this in the right order, is to grab an and thunk it down right there. Oops. Move my wire back a bit. If I wire these two together, and then I program an association or a link between the channel 2 mute and the second logic source, give them a second to get synchronized, I've now created a circuit which says mute the logic end, or mute the master mute by turning on the logic end whenever 1 and 2 are both on. So when mutes 1 and 2 are both on, the master mute comes on. If either one of them is unmuted, the master mute unmutes. Alright? If I unmute channel 1, it unmutes the master. If I unmute channel 2, it unmutes the master. Moderately useful. Even that one's not all that cool, though. The cool stuff is the offshoots we can do from that. Let's look at the logic pulse. Oops, wrong button. The logic pulse, under properties, first of all, double click on the logic pulse and you'll see that there's no control panel. Very few logic objects have control panel. It's almost always set up in properties. The logic pulse has an on time and an off time. How long is it turned on and how long is it turned off? It's currently set for a half second each way. I'm going to change the on time to 1 second, and the off time to 2 seconds. Make it a little bit easier for you guys to be able to see it over WebEx. Otherwise, you'll never see it actually flash. Now, if I take another logic end, and I wire it right to it, get over there. What are we going to have? We're going to have an end that flashes at the same rate as the pulse. So now let's have that end be influenced by our original mute circuit over here. What if we pull back this logic, stick our old buddy the AND gate in here, come on. There we go. So now what's going to happen to the output of the and therefore to the logic end? Nothing is going to happen. Because the output of the AND can't come on unless both inputs of the AND are turned on. If I were to take the output of the AND and wire it directly to the master mute, now whenever the master mute is on, that logic end is going to flash on and off. If I grab a knot and drop it in there, and reverse that signal coming from the master mute, now when is the logic end going to flash? The logic end is going to flash whenever the logic pulse goes off and not the master mute. So when the master mute is open, the red light's going to flash. I think the technical term we're looking for is on-air indicator, isn't it? Is that what we're talking about here? Is that exactly what I just described? Pink. How did I get pink? I want pink. Bright red. There we go. If I go back to my control panel, nothing's happening. It's just a normal old control panel. If I unmute something, all of a sudden the red indicator starts flashing every 2 seconds. Not bad as an on-air indicator. And you can then tie that to a control port, plug it into an LED, have it trigger a light, a relay, whatever, so that you know when the system is being used. What else can we do here? We also have a calendar processing object. There we go. Move this out of the way a little bit. What does the calendar processing object do? Well, it doesn't do anything based on the control panel. But if we look over in properties, it does quite a bit. We click on the click button to edit. We can add triggers to the calendar object. Each trigger is an on trigger or an off trigger. Your choice. So I can tell this to turn on turn on at 5. Oops. Why is my mouse not, or my keyboard not working? There you go. 5:05 p.m. Turn on this calendar object at 5:05 p.m. starting on October 1st and recur every 1 day. I can tell to at 7:55 a.m. starting October 1st, turn itself off and recur every 1 day. So what's going to happen? At 5:05 p.m., this calendar object is going to go high. At 7:55 a.m., it's going to go low. It's going to turn itself off. Okay, so what good is that? Well, if we grab the wire and pull it back here, slap an OR object in there, what does this wire right here do for us? What does it tell us what's going on? That wire is the master mute. It used to be the master mute would come on when source 1 and source 2 are both on. Now, if we wire it up like this, master mute will come on when source 1 and source 2 or the calendar is on. That's what will cause the mute condition. So if I have my mics unmuted, come on. There we go. Move that out of the way so you guys can't see it. That's my Windows clock. If I tell my Windows clock that, you know what, it's now after 5 p.m., watch that logic end. Watch the status for mute. Cool. It's going to mute the system at 5 p.m. and unmute at 7 a.m. or 7:55 a.m. So 8 o'clock in the morning. This is a real situation from a college library. In the basement where they used to have all their magazine stacks, they've put in all these micro conference rooms. It's a performing arts and media college. And these micro conference rooms, they're really kind of cool. They've got Extron panels, plates, input plates on the wall, and it's the exact same Extron plate they have in all their classrooms. So the same connectors and the same controls. That plate in the little mini conference rooms feeds an LCD, which happens to have exactly the same resolution as all the projectors in their classrooms. So the students can plug their laptop in here and know they're dealing with the exact same resolution, the exact same controls, and practice working on their project. Unfortunately, it's down in the basement. There's no staff down there at night. So they wanted a way to not have to worry about students going down there at night, plugging in their iPods, cranking up the tunes, and blowing things up. The solution was to simply block access entirely after hours. You can still go down there and sit and study. You just can't use the AV system because it's turned itself off. Very cool solution for that facility. What would have happened if you were working on that project and the customer had come to you and said, you know, by the way, with these 14 conference rooms, I'd like a way to prevent the students from being able to use them after hours, but I don't want to go through and put locks on the doors or any of that sort of thing. So what can we do to automatically turn off the system every night? You probably would have thought Crestron, AMX, Medialon, Extron, one of those control systems, right? No matter how inexpensive the control system you're thinking of is, I guarantee this Logic program costs less. Presuming, of course, you're already using sound blended devices, which this facility was. They're already passing sound blended, or passing the audio through a whole bunch of Blue 16s to process the audio. This was, I don't know, maybe 10 minutes of thinking and 5 minutes of actual work to implement. Nothing to it. And once you go down that road, you can start adding all kinds of cool stuff and having all these great change orders. For instance, the university then said, oh, now wait a minute, we have to have some way to make the system work during the week, but not work on the weekend. Oh, all right, well, no problem. We'll go back to our calendar, and we'll just go in here and we'll put a master mute on trigger at 7:55:01 a.m. starting on Saturday the 4th and recurring every 7 days. put another one in here that does the exact same thing on Monday. 7:55:01 a.m. And by the way, it changed from a.m. to p.m. You just hit the A button or the P button. And this one's on Sunday the 5th for the first time. Turn on the master mute. Recur every 7 days. Hit OK. And send the change order for the, quote, additional programming fee. Cool. Now the system unmutes itself at 7:55 a.m., but on Saturdays and Sundays it remutes 1 second later. Because there's no staff in there on Saturdays and Sundays. And then they come back and they say, oh, that's great, but we forgot during finals week there is staff down there. The week before finals week, I mean. You know, the week before finals week is when all the presentations are due and students are needing those rooms and they're backed up and reserved for weeks in advance. And we need to be able to run them late at night and on the weekend. No problem. We'll grab our line coming out of the calendar, drop it right there. We'll grab our happy little and, make a copy of it, attach that to the wire that came out of the calendar, plug the calendar into it, and then I need a logic source. So what did I just do? I created a situation where the logic or the calendar activity is ignored. It's an override master mute, right? So the calendar is ignored unless this logic source is turned on. So what do I do with that logic source? Well, I take it over here. I go to my blue 16. I go to the control ports. And I throw that button from that logic source onto the first control port. Then I take that control port and I'll wire it up to that $1.79 key lock switch that Mid-Atlantic sells for the racks. I mount that in the side of the rack and I give them a key. And say, here you go. If you turn this key to the on position, the system will work 24 hours a day. If you turn this key to the off position, it will only work during the week. This is your master override. And by the way, here's my bill for a lot more than $1.79. And if you want to get even fancier, you can use the momentary contact switch so they can't accidentally leave it on. They trigger the momentary contact with the key, and we set up a logic circuit that'll go on and lock itself on and reset itself at 7 a.m., 8 a.m. So they can pop the key in, hit it, it's good for tonight. Or pop the key in, hit it, it's good for 4 hours. Whatever we decide to program. Very, very simple to do. You can do very cool stuff that your customers will be blown away by using very little logic. If you think about it, what have I touched so far? Logic source, logic pulse, and calendar, and or not, and logic end. 7 objects. That's all we've even looked at so far. So what about some of these other objects? What the heck can we do with them? We looked at the Booleans. Let's look at some of the other stuff down here. The counters. Counters are fun. I'll show you a logic macro here before the end of the class that uses counter shifters to do some cool things. A counter shifter can be set in binary mode or shift down mode. It has an input, an R for reset, and a D for direction. As long as the reset is held high by something, nothing happens. It never changes. This one is set on shift down, this one is set on binary. But if I turn off that reset, the shift down starts shifting down. Every pulse, it moves down 1. The binary one starts counting in binary. There's 8, 9, locked in. Alright? That's the counter shifter. The counter trigger, very similar. Pull this over here. Oh, and the counter shifter, other than mode and number of outputs, has no settings. You can change it from binary to shift down right here. And you can change the number of outputs to 24, no, 32. 32 outputs. The counter trigger, on the other hand, has a count setting. You have to set the count on it. This one is set to 3. It has an input and an R for reset. What that means is when I turn off the reset, on the third input pulse after that, the output will turn on, and it will stay on until I pulse the reset. So here we go. Turn off the reset. There's 1 pulse, 2 pulses, 3rd pulse, and the output turns on. So you can keep track of events that way. If you want something to happen on every 3rd pulse, for instance, or every 20th pulse or whatever, in this case we'll call it 3rd pulse, I already have it wired up that way, or programmed that way, I can wire the output straight back to the reset. Move this out of the way so you can see. And we'll assume that my output goes over here and goes to a logic end to do something. I don't know if you guys will be able to see that through WebEx or not. Let me watch it one time on the monitor computer. Yeah, you can just barely see it flicker. There's a second one. Another second one, I'm sorry. There's the 3rd one. See that flicker on the end? Here comes another one. That flicker is the counter trigger going high and then resetting itself. So for 100 milliseconds, it's high, which is more than enough time to cause whatever I want to have happen out here, to trigger some event. So now every 3rd pulse of the input, I'm getting a logic end trigger. I can combine these 2 objects, the logic, or the counter trigger, and the counter shifter. Counter shifter has a very unique ability in that, if you think about it, what happens if you take a binary counter shifter and give it only 1 output? Well, now suddenly it's shifting back and forth between 0 and 1, right? So what is this circuit going to do in total? Every 3rd input pulse, it's going to either turn on or turn off the counter shifter. There's the 3rd pulse, it turns it off. The next 3rd pulse comes along, it's going to pulse the input to the counter shifter and turn on. So you can do all kinds of weird combinations of things, depending on what you're trying to accomplish with counter shifters and counter triggers. There's also an object called a logic delay that does not work the way you think it works. So I will explain how it actually does work. Here's the logic source going to the logic delay. The logic delay has a delay on and a delay off time. And it's set in ticks, 100 millisecond ticks, just like a logic pulse is. So if I set the delay on to 30 ticks, that's 3 seconds. I go over here to the logic source and I turn it on. Watch right here. Turn it on, the input goes on. 3 seconds later, the output goes on. Turn it off, it both happens immediately because my input, my delay on is set to 3 with 30 ticks, my delay off set to 0. If I reverse them and turn it on, the output goes on immediately. When I turn it off, 3 seconds later, the output goes off. So far, it's looking pretty much like an analog audio delay, right? Okay, here's where it gets weird. We're set to an off time of 30 and an on time of 0. Let's turn it back on. Now, I'm going to turn it off, turn it back on, 3 seconds later, and nothing. Turn it off, turn it back on, 3 seconds later, nothing. The logic delay is not delaying a signal. What it's doing is delaying its own reactions. It's saying, if you want the output to turn off, then the input must be off for that many ticks before triggering the off. Look right down here in the little help area of the properties window, the little explanation window. The number of logic ticks to count before triggering off. So when you turn off, it's going to wait 30 ticks before triggering off, and the input must stay off the entire time. I reverse those. Set the delay on to 30. Turn it off. Now I can have press the button, release the button. 3 seconds later, nothing. Press it, release it. 3 seconds later, nothing. Logic delay is a great little tool to use if you have a momentary contact button in the real world. Let's change this over to momentary. And let's say this logic end is causing something major to happen in your system. You know, it's recalling a preset or it's changing something major. If I bump this button, do I want to have that event trigger? Probably not. By setting the logic delay to 3 seconds, I can say, okay, press and hold the button for 3 seconds, then it'll trigger. You want to send a command that turns on the overhead fluorescent work lights in the theater, the ugly lights. You better press and hold that sucker for 3 seconds before it really works. That might not really be what you mean. If you want to be doubly safe, because that's another example of a real world situation that I programmed for somebody, except in that situation, we took the logic end, went to our gallery. I don't have any WAV files loaded. Anyhow, we put a WAV file on the logic end, and then had a second logic delay, also set for 3 seconds. So they actually had to press and hold the button for 6 seconds to make it happen. At the end of 3 seconds, a little logic end caused the computer to start going, "Are you sure? Are you sure? Are you sure? Are you sure?" in the stage manager's voice. It was pretty funny, actually. "Are you sure? Are you sure?" You got to listen to 3 seconds of that before the ugly lights would come on. So it's a great way to make things safer, to eliminate the possibility of false triggers. It's also a great thing to use on fire system relays, fire system inputs. The worst thing in the world is when that fire system resets itself. Oh man, every time they reboot the fire system, it loses connection for a split second and triggers who knows what kind of chaos in your audio system, whatever you programmed in there. Okay? Normally, a fire system is going to be normally closed contact. Hello, get over there. There we go. So it's going to look like that most of the time. What I've done is I go into the logic delay and I set it with a delay on of 0 and a delay off of 3 seconds. And I go to the fire marshal and I say, listen, is it okay when the fire panel goes into alarm if the audio system waits 3 seconds before it responds? And I explain to him why. I explain so that when the fire system just reboots itself, we're not getting false triggers. I've never had a fire marshal say no. I've never had anybody say no once I explain the system to it. And if you watch, here's how it's going to work. I'll bring this back over so you can see them a little more easily on the screen. When the fire system glitches and does a reboot, that's what we'll get, and the output is unchanged. So we don't even notice it. When the fire system goes into actual alarm state, 3 seconds later, we mute the audio, do whatever they're supposed to do. Just like we're supposed to do it. Great way to make things simpler. I just realized I'm wasting bandwidth on this stupid little red flashing light over here. Let's change that pulse to, I don't know, about a week and a half off. There we go. That'll only pulse once every time I switch. So that's the logic delay. If you need a longer logic delay, because the logic delay is set using ticks. Again, it's 100 millisecond ticks. Those ticks are not necessarily accurate. In fact, I'll even leave the word necessarily off. They're not accurate. Those 100 millisecond ticks, they don't last 100 milliseconds. They last at least 100 milliseconds. If the CPU on that blue box is busy doing something else, it might not get around to the logic until 103 milliseconds, 104 or 5 milliseconds. If a great big humongous serial command comes in right at the wrong second and it's triggering a bunch of presets, it could be 108, 110 milliseconds before the device gets around to it. Now, realistically, if you're talking about the difference between 3 seconds and 3 seconds plus 18 milliseconds, probably not a big deal. However, if you start trying to use the logic delay to set 9, 10, 12, 20-minute, 30-minute delays, your margin of error gets really unacceptably huge really fast. That's why there's a thing called a logic timed delay. It's the exact same object. It works exactly the same way, except it's programmed in seconds instead of 100 millisecond chunks. That's the only difference. And it runs off the actual system clock instead of being based on CPU timing. So let's say your device is really busy and you try and set a 10-minute delay. Well, that 10 minutes is going to be wrong by up to 2, 3, 4, 5% by the time the logic delay gets done calculating it, because you could have that 2, 3, 4, 5, 6, maybe 10% overrun on every cycle. With the logic time delay, there's only one cycle, the last one, that matters. So your 10-minute delay could be 10 minutes plus 8 milliseconds, plus 6 milliseconds. It still won't be dead on, but it's going to be way close enough for anything that matters. If you need better than 10 millisecond accuracy, you probably might want to look at something more expensive as a solution. Single pulse trigger we're not going to get into today, even though we have a little extra time, just because it's kind of a catch-all object and you're not going to understand it until you need it. So remember this about the single pulse trigger. If what you need is a pulse which starts off and then turns itself on and then turns itself off, if you need an off-on-off pulse, the single pulse trigger will take pretty much anything you want to give it, whether it's a press and hold, whether it's a release and hold, whether it's a multiple press, whether it's a stuttering input, whatever. It'll take that and convert it into a off-on-off pulse. Starts in the off position, turns itself on, then turns itself back off. That's what it does. So what other cool stuff can we do? Over here on the output section, let's look at some of this stuff, because there's more stuff I can show you in the middle, but let's look at the output first. So this is what actually does things. All we've looked at so far is the logic end. The logic end, the preset trigger, the preset table, and the serial trigger table. Well, once upon a time, logic end is all we had, and logic was a pretty boring place to live. And then Graham gave us the preset trigger. Ooh, cool. Here's how it works. We create a parameter preset group. And create 2 parameter presets. Actually, let's go this way, it's easier to see. The preset trigger can activate those. When the preset goes high, I want to activate parameter preset number 1. When it goes low, I want to do nothing. Alright. So I'll come over here with my little button. When I press this button on, actually it's already on, I'll turn it off. When I turn it on, it recalls the preset and slams those faders up. Turn it back off, nothing happens. Somebody moves a fader, I put it back with the preset. If I assign a different preset to the off condition, then it'll trigger on off. That's a preset trigger. A preset table is a very similar beast. You put 3 inputs on there. Imagine if I had 3 preset triggers. How many possible presets could I express with 3 preset triggers? Well, we have an on and an off for each one, right? So it's a total of 6. Well, a preset table treats its inputs as a binary set. So instead of input 1, input 2, input 3, it's byte 1, byte 2, byte 3, bit 1, 2, and 3 of a 3-digit byte. So in my properties, I have 8 places to assign presets based on the combination of those input conditions. If I give this 6 inputs, all of a sudden I have a lot of combinations. If I crank it up to the max, but I think it's 14, no, 12. Crank up to the max of 12 inputs on that preset table, I've got 4,096 possible combinations of inputs that I can trigger presets off of. I don't have to use them all, but I can set up very precise conditions under which only in this condition will this preset trigger. Cool. And then one day, finally, hallelujah, Graham gave us the serial trigger table. Now, because it came along late, he went ahead and wrapped up the trigger version and the table version all in the same processing object. You've got a little mode of operation button here, which for whatever reason calls it list and table instead of trigger and table, but okay. Number of inputs. Again, you have up to 12 inputs. And the way this works is, if I have a single input, all I have is 0 and 1. When we go to the 0 state, what serial string should I send out the serial port in the back of the device? When we go to the on state, what serial string should we send? I'm in the middle of programming a boardroom for a university where they have the ability from the control panel or from the Blue 10 to turn on and off their projector, as well as control the input selection, all the various things like that. If you hit the button for the DVD player, the projector switches over to the DVD player video source, and the Blue 80 switches over to the DVD player audio source, all from one logic section, one logic chain. So the serial trigger table is a very cool processing object. It allows you to control external devices with the Blue 16, Blue 80, Blue 32, whatever. There we go. The end objects, the triggers and the tables, are complemented by another set of input objects that we haven't talked about yet. Just like you can trigger pretty much anything with the output devices, you can trigger from pretty much anything with the input devices. Now remember, we said, logic is cool, but it's only really cool when you link it with audio. Question was, are there any serial in objects? No, there are not. I have been begging and pleading for that for a long time. They keep telling me someday. The logic needs to be controlled and triggered and based off of audio, right? That's why we're here. Logic source. We already played with the logic source. What does the logic source do? Well, it links to any discrete state object that only has 2 states. In other words, it links to buttons. It links to buttons on your control panel. Okay, cool. But what if I want to trigger something off of the position of a rotary or the value of a fader? That's the Logic Comparator. if I grab the master fader over here, oops, I think I missed. There we go. And associate it with that Logic Comparator. The Logic Comparator has a control panel. And it shows you the current value of whatever is associated with it and its trigger value. And then under properties, you can decide what to do with that trigger value. I'm going to say if my compare value is greater than or equal to the compare value, then I want this thing to light up. Come here, wrong button, there we go. Now you notice I'm at negative 0.87 dB, and the light just went off over here. If I push it back up above 0, 1.04, the comparator comes on. So I can change these based on, change things based on the position of the fader. And if I want it to be negative 3.5, all I have to do is come down here to the control panel, hit the copy button, and it'll take the current raw value and paste it in right there. So now the fader is responding to negative 3.5. If I'm below negative 3.5, no big deal. So they get above it, light comes on. And this little copy button can be placed wherever you'd like it to be. It can stay on the default control panel, or you can bring it over here and put it in your custom control panel. This can actually be very useful. Let's take a logic end. Wire it on here. Come on, you can do it. There you go. And I'll place the indicator from the logic end on my control panel. Oops. There we go. Let's just stretch this turkey down here real quick. Oh, wrong button. There we go. I really hate these regions. There we go. We'll do a, well, let's make it red first, I guess. No use putting it there if we're not going to make it obnoxious, right? But we'll make it only 50% opaque when it's on. And then send this to the back. So what did I just do? Send to back. Thank you. So what did I just do? I've got this set up with the button on my screen, so I can change the assignment anytime I want. Why won't it stay in the back? There we go. Get up here and be happy with me. I can change the assignment anytime I want. I wired up to the logic source, not the logic comparator. You guys just watched me do that, didn't you? So now if I'm above my compare point, my background turns red. If I'm below it, it turns blue, and I can change that compare point. If I decide, okay, right here's my point, I got to remind myself not to go above that point. Or if I decide down here's my point, I got to remind myself don't go above that point. Or be aware that I'm doing something different if I go above that point. And I can either preset that point or dynamically change it with a little button. That can be very, very useful. Tonight we'll, at the end of sound check, we'll push the button. Now it's not a perfect recall, but we can always get our rough spot back by going right to the edge of the red. If you want to be tricky with it, you can set your comparator to equals instead of less than or equal to. And now it's just going to flash red as you go past your point. I don't know where I left my point. There we go. Just get that flicker that goes by. So that's the Logic Comparator. What else do we have for control panel objects in the audio world? We have buttons, we have faders and rotaries, and we have, ding, that's right, source selectors. Take a source selector, drop it onto a logic value. The logic value now indicates the currently selected source. Source 1, source 2, no sources. So you can change things in the system based on which audio signal is selected. This is the easy way to make your projector follow along with your audio. Just put in the audio selector, and when the audio selector says, I've selected CD, obviously there's no video signal for CD, so you mute the projector. If this one is DVD, then have it trigger the DVD to the projector, or whatever the case might be. That's the logic value. Any questions on that stuff so far? It's all making good sense to you? Either that or you can't remember how to get to the chat window to ask questions. It's always possible. I lost my window. Let's go back out here. Because I want you guys to have a few minutes to play with this stuff so you can generate some questions, we're going to, usually I take a 10-minute break during my class at the top of the hour. We're going to go ahead and make this almost a 20-minute break. It's 4 minutes till right now. So we'll go ahead and call it a 19-minute break. What just happened? Apparently I can't type. I certainly can't type quickly. We'll do a 19-minute break, and I want you to play with these logic objects and do some associating and create some logic chains during the break, and see if we can generate some questions about this stuff. After the break, we're going to come back and look at some more advanced processing objects and some of that fun stuff. The bottom right-hand corner of your screen has opened up a little poll, which you can ignore. It's just called 19-minute break. But that gives us a nice little timer there. So when the timer runs out, we need to all be back here. That way you can check and see how much time is left in the break.